In this lesson, I'll show you two examples on how to test for convergence using the Cauchy ratio test with infinite series. This is part one. The conditions for the Cauchy ratio test are shown right here, where if the limit as n approaches infinity is less than 1, the series converges. If it is greater than 1, the series diverges. And if it is equal to 1, then the test fails and is inconclusive. Let's start with question number 1. They ask, use the ratio test on the following series to determine if it converges or diverges. Let's take a look at this and set this up. We have the limit as n approaches infinity. So I'll write down the limit as n approaches infinity. And I'll take the expression that's shown here, which tells us that wherever you see an n in your general series, you write down n plus 1. So instead of this n, we write down n plus 1. And instead of this n, we write down e to the power of n plus 1. And we divide this by our general form, which is n over e to the power of n. If we divide these two, the second fraction will flip, and this will become multiplication. Next, I'll use the laws of exponents, and the laws of exponents tells us, namely the quotient rule, that if you have the base that's the same, in our case we have e, we can take their exponents, n, and subtract it with the exponents of this e. So technically we have n minus this thing, n plus 1, n minus n minus 1, n minus n is equal to nothing. And so we have e to the power of negative 1. And on top of that, we have n plus 1 over n. This e to the power of negative 1 can be placed at the bottom. So we have n plus 1 over e to the power of 1, which I'll just write down as e times n. And of course, at this step, I can multiply the top and the bottom by 1 over n to clear this n, where we get 1 plus 1 over n over this n and this n cancel out, leaving us with only e. Now we can actually take the limit of this expression. Whereas before, at the very beginning, we weren't able to. We would end up with something like infinity over infinity, and then we won't be able to perform the test. So if I substitute n approaching infinity into here, this thing will become technically 0. 1 over a very large number is equal to 0. And we have 1 over e. 1 over e, if you evaluate it on your calculator, will give you a number that's less than 1. And according to this test, that if you get a limit that's less than 1, this series converges. Let's move on to question number 2. In question number 2, we're asked, what does the ratio test say about the convergence or divergence of the following series? We'll set it up the same way. We had the limit as n approaches infinity. And we started off with adding n plus 1 where there were n's. So we have negative 1 to the power of n plus 1 over, and over here I'll write down n plus 4 because n plus 1 plus 3 is n plus 4, raised to the power of 4 divided by our original series. Let's manipulate this as best as we can. What I'll do is flip this fraction and change this to multiplication. If I do that, I'll end up with this expression. Using the laws of exponents, just like in question number 1, we have the same base, so we can subtract n plus 1 minus n. That will give us simply negative 1 to the power of 1, which I'll just write down as negative 1. And at the top we have n plus 3 to the power of 4 over, at the bottom, n plus 4 to the power of 4. Rewriting everything else, we're almost done here. Next, we can rearrange this where this negative 1 can be placed on the outside, and given that these expressions both are raised to the power of 4, I can rewrite it as one quotient raised to the power of 4. And there it is. I've morphed it into what I was talking about. Now, if I take the limit as n approaches infinity here and here, I'll end up with technically infinity over infinity. If I factor out n from the top and the bottom of this fraction, the n factors would cancel out, leaving us with the expression shown on your screen. Taking the limit of this expression gives us 1. So we can say that this will go to 1. 1 to the power of 4 And we also have a negative 1. So 1 to the power of 4 is 1 times negative 1, that's negative 1. Since the absolute of negative 1 is equal to 1, our test tells us that if it is equal to 1, the test fails to give any conclusive information. So over here, this is inconclusive. And so there you have it. 2 examples on how to test for convergence using the ratio test with infinite series. Make sure to watch part 2 for some more challenging examples.